Hare Krishna. First, we'll see some partial fraction sums, then, we'll go to convolution theorem.
So in this type of question, we cannot divide the denominator, so we need to use partial fractions because then we can, by linearity property, we can simplify. No, so we'll see how to do inverse Laplace transforms using partial fractions. So first, consider. I think you know partial fraction formulas. If linear is there, on numerator we'll take constants. If quadratics are there, then we'll take linear in the numerator. It works like that. So firstly, 1 by s plus 1 into s plus 2 can be written as a by s plus 1 plus b by s plus 2. Because these are linears, I'm writing constants a and b. So now we have to solve this. For that, 1 by s plus 1 into s plus 2, cross multiply a into s plus 2 plus b into s plus 1 by s plus 1 into this. So this and this get always cancelled. So we will be left out with this statement. So now we can either compare coefficients. Okay, so let's do that. This will be as plus bs plus 2a plus b. So what is the constant here? 2a plus b is constant. This side constant is 1. And also this side coefficients of s is a and b, no, a plus b. This side coefficient of s is 0. So we can write a plus b is 0. Comparing coefficient of s, comparing constants, we can write 2a plus b as 1. So from here we get a is minus b. From now we can use calculus if you want. So from here we get minus 2b plus b, which is minus b. So b is minus 1 and a will be 1. So now we have to write these values here. Okay. So let me write it here. Therefore, 1 by s plus 1 into s plus 2 is equal to 1 by s plus 1 minus 1 by s plus 2. Okay, b is minus 1, I kept minus here. Next, now we have to find Laplace inverse. Now it's easy to find because it by linear property we can write as Laplace inverse of 1 by s plus 1 minus Laplace inverse of 1 by s plus 2. So which will be using which property? Laplace inverse of 1 by entire formula we can write e power minus t. This will be e power minus 2t over. So in this type of questions, here we should consider s plus 1 whole square s minus 2. We should consider it as a by s plus 1 plus b by s plus 1 whole square plus c by s minus 2. So why did we consider like this? Whenever we have linear term and it have some powers, so we should take it as like this: s plus 1 whole square. If cube is there, s plus 1 whole cube. But on top we write only constants because these are linears only, no? So we don't see it as quadratic. So all these models we should take them like this only. Okay, now we have to compare, write the next step: s by s plus 1 whole square. So this will be getting all what is a common, you can get s plus 1 whole square into s minus 2. Now this step is important. Here I'm writing my numerator. My denominator is s plus 1. How many more do I need to multiply? S plus 1 and s minus 2. Next, b into s plus 1 whole square. What more should I multiply to get this denominator? I should multiply s minus 2. Next, c is there. S minus 2 I have. What more I have to multiply? S plus 1 whole square I have to multiply to get that denominator. Okay, so now we have to this is s plus 1 whole square. So now this both get. So in this type of questions we can use this method. Put s is equal to minus 1, then put s is equal to 2. Okay, this way we can easily get zeros everywhere. So let's put it. Putting s minus 1 this side, then this side will get, this will become 0, this will become 0, only b will be left. So b into s is minus 1, so minus 3b. So what is b? B is 1 by 3. See, we got one value very easily. Next, put s is equal to 2. So this side will be 2. This side will be 0, 0. This will be left 2 plus 1, 3. 3 square is 9. So 9c. So c is 2 by 9. So we got two values. Next, to get a value, either you put s is equal to minus 1 or s is equal to 2. This won't work. So how to get a value? this will compare coefficient of s. So this side, see, coefficient of s is 1. So write comparing coefficient of s. So this side is 1. So 1 is equal to this side c coefficient of s. This is s square. Okay, you'll get s square. Then you'll get minus 2s plus 1s means minus s. For that we'll get. So one coefficient is minus a. Okay. Next from this you'll get bs. Next you'll get s square plus 1 plus 2s. You'll get 2s coefficient, so 2c you'll get. So from this we'll get b substitute 1 by 3. 2 substitute 2 by 9, so 4 by 9. That it will go, it's go that side and this comes this side. So minus 1 plus this value minus 2 by 9 a value. So then you'll write here, therefore s by s plus 1 whole square into s minus 2 is equal to minus 2 by 9 by s plus 1 plus 1 by 3 by s plus 1 whole square plus 2 by 9 by s minus 2. Now by linearity property, so this value will be linearity of this value, minus 2 by 9 into s plus 1 inverses e power minus t. Okay, this one plus 1 by 3, this one see s plus 1 whole square. Which property we should use here? Shifting property, right? So I'll shift my s plus 1 to s. So I'll write linear in 1 by s square, and outside I'll write e power minus t. Okay, plus what is this? S minus 2. So directly I can write e power minus 2t plus 2t because here minus is there. Okay, so what is the final answer? Minus 2 by 9 e power minus t. Laplace inverse of 1 by s square is t plus 1 by 3 e power minus t into t plus 2 by 9 e power 2t. So this is your final answer. So this using partial fractions, how will you divide? S by s plus 1 into s square plus 4. So we get quadratic. So we'll write a by s plus 1 plus bs plus c by s square plus 4. So using other constants, I am making a linear function in numerator because this is quadratic. So now s by s plus 1 into cross multiply a into s square plus 4 s plus 1 by, so these two get cancelled. So now can we put s is equal to minus 1? Yeah, so this will be 0 and we'll get some value here. So putting s is equal to minus 1, we get minus 1 is equal to 1 plus 5a plus 0. So a will be minus 1 by 5. Clear? Next we need to find b and c. So how are we going to find that? We'll compare coefficient of s square. Compare coefficient of s square. So this side is 0. This side it is bs into s will get s square. So it is a and b. Therefore b is 1 by 5. Okay. Next we need to get c. For that we'll compare coefficient of s. So here s coefficient is 1. Compare coefficient of s. 1 is equal to this side. Here as square plus 4a, and next to bs square plus bs will get 1 b. Next to cs plus c will get 1 c. So b is 1 by 5. So c is 1 minus 1 by 5, which is 4 by 5. So we got all values. So now simply substitute here. So here a by bs plus c by. Okay. Now we will, by linearity property, we know that minus 1 by 5 Laplace inverse of 1 by s plus 1 plus, again dividing this like this and like this, we can write directly Laplace inverse of 1 by 5 s by s square plus 2 square plus Laplace inverse of 4 by 5 by s square plus 2 square. Now which formulas we have to use for this? E power minus t. And here we have s by something, means cos plus is a, so cos 2t. So 1 by 5 cos 2t. Here we have 4 by 5 into 1 by s square plus 2 square. So it is sine 2t by 2. Don't forget 2. Okay, this is your final answer. Next, we'll find another sum. So we'll directly go to convolution theorem. Anyway, in the middle of convolution theorem, we'll get many partial fractions to do. So we'll practice there more. See, convolution theorem states that let f of t and g of t be two functions, okay, defined for t greater than 0. Then by definition we'll write f of t into g of t is integral 0 to t f of u into g of t minus u du. So we have to change the t to u such that we'll, for small functions that you know very well, we'll keep u, for easy for difficult functions we'll put u, and for easy functions we'll take t minus u. And next, so this is the statement: if Laplace of f of t is f bar of s and Laplace of g of t is g bar of s, then we can write as Laplace of f of t into g of t as f bar of s into g bar of s. So until now we have seen some linearity property where I told if there is plus or minus we can write it Laplace of f of t plus Laplace of g of t, right? So now it is about into. So if we have into, directly we can write it as f bar of s into g bar of s, which is nothing but this only, Laplace of f of t into Laplace of g of t. So which again we can write in inverse form as this, Laplace inverse of f bar of s into g bar of s. So basically we'll go to questions to understand more. So you'll be given like this: using convolution theorem find some inverse. It will be given for you. So first what you should be doing is you'll consider two functions f bar of s and g bar of s, and then for example 1 by s plus a is my f bar of s and 1 by s plus b is my g bar of s. Immediately you'll find Laplace inverse. So I told you the very starting why you should be applying Laplace inverse, means wherever s is there we apply Laplace inverse, wherever t is there we apply Laplace. I told you very before. So Laplace inverse of f bar of s, which is e power minus at. Now this got converted to t, so I will write this as f of t. So this is my other function, so I took it as g of t. So these two statements first we'll write. Next, by convolution theorem we'll write all this. Laplace inverse of f bar of s into g bar of s is f of t into g of t, which is 0 to t f of u into g of t minus u du. So now we have, so how do I get my f of u? In place of t, if I put u, that will be my f of u. Therefore, let's write f of u is equal to e power minus au, and g of t minus u means I should put in place of g of t, here I should put t minus u. That will be e power minus b into t place lo t minus u. Okay, so this is my f of u and this is my g of t minus u. Now I am substituting in this integral. Therefore, f of t into g of t is equal to 0 to t e power minus au into e power minus b into t minus du. So next we'll write a power m into a power n a power m plus n. So we can write it as e power t e power minus bt minus au and minus au. So here t is constant because we are doing integration with respect to u. Therefore we'll keep only inside u terms, minus au plus bu. Okay, I'm taking e power minus bt outside because this is constant. Okay, so next this is du. So we'll get e power minus bt into, what is integral of e power x? It is e power x by, okay, now here we'll do inner integration, e power b minus a into u by, constant is b minus a. So integrals limits are from 0 to t. So now where should I apply this limits? These are my u limits, so I should apply in place of u. Okay, so we'll get it as e power minus bt, e power b minus a into t by b minus a minus lower limit anything to the power 0 is 1, so 1 by b minus a. So we multiply this inside, bt get cancelled, we'll be left out with at, e power minus at by b minus a minus e power minus bt by b minus a. Okay. So next, solve Laplace inverse of 1 by s into s square plus 4 by convolution theorem. So if it question convolution theorem is not mentioned, by which method you want to do, you will prefer to do by partial fractions, which is very easy. You will divide a by s and bs plus c by s square plus 4. Easily you will get fractions and you will do it very easy. But if they ask you to do by convolution theorem, you should do it in this way only. So here my f bar of s is 1 by s, g bar of s is 1 by s square plus 4. Then Laplace inverse of f bar of s is 1. Laplace inverse of g bar of s is 2 square. So it will be sine 2t by 2. Okay. So this is my f of t. This is my g of t. By convolution theorem, so write the whole statement. Laplace inverse of f bar of s into g bar of s, f of t into g of t is equal to f of u into g of t minus u du. F of t is 1, f of u will also be 1. G of t is this, g of t minus u means sine 2 into t minus u by 2 du. So now 1 by 2 I am taking out common, not common outside. Then we'll be left integral of sine of something. So this will be minus, derivative I'll get minus 2. Limits are from 0 to 2, 0 to t. Then I'll get 1 by 4. So in which place I have to put? In new place. So t I am putting, t minus t will be 0, cos 0 will be 1. Next 0 putting here, cos 2t I'll get. So this is my final answer. So here evaluate this by convolution theorem. So f bar of s is 1 by s, g bar of s is 1 by s square plus 2s plus 2. So my Laplace inverse of f bar of s will be, Laplace inverse of 1 by s is 1. Laplace inverse of this whole term, can you find out? No. So let's write it like this, Laplace inverse of 1 by that term. Before we already did these kind of sums, I told to check first for s plus 1 whole square, which is x square plus 2s plus 1. So here x square plus 2s plus 1 is there, so we'll write s plus 1 whole square plus 1. Then by using shifting property, we can shift Laplace inverse of 1 by s square plus 1 square, but outside I should write e power minus t by shifting property. Then this will be my e power minus t into, what is Laplace inverse of this? 1 by sine t. Sine t. So this is my g of t. This is my f of t. So we got two, f of t and g of t. Now then by convolution theorem, write the whole big statement. Laplace inverse of f bar of s into g bar of s is f of t into g of t is f of u into g of t minus u du. So what is my f of u? 1 only. F of t or f of u both are 1 only. G of t minus u means in place of this I should put e power minus t minus u here, and here again sine t minus u. So if you want, you can do it in that way. or else directly I'm taking, instead of f of t, this will be my g of t, and this I can take of f of t. There is no problem in taking it reverse. Simply we'll write here g bar of s and f bar of s, or we can consider g of t and we can write in exam also. So why? Because we want to put t minus u in easy function so that we don't get the question lengthy. So you can write, consider fg of t as 1 and f of t as e power minus t sin t. Then you will write, so now what is my f of u? Putting here u, in place of t put u, you will get e power minus u sin u. What is my g of t minus u? Anyway, it is going to be 1 only. So in this method, you can use one formula here, e power at sin bt. This we have in inter. So the formula is e power at by s square plus b square into a sin bt minus b cos bt. So this we'll write in our formula sheet also. What is the formula? Integral of e power at sin bt. E power at by, write along with me in your formula sheet. Okay. Write convolution theorem also in your formula sheet. Okay. Next. So to solve this. So here what is my a? See, this is with respect to t, and here we are doing with respect to u. So please be very careful while solving this. So here my a is minus 1. Okay. And right here a is minus 1. What is my b? B is also 1. B is 1. Okay. So now by formula this is going to be e power minus u. In place of t we are doing u with respect to u. A is minus 1 and t is u here. By a square plus b square. 1 square plus 1 square is 2. Into what is a? Minus sin bt. Minus sin b is 1, so minus sin t. Okay. Oh, I got it wrong. This is u. In place of t we are writing here u, no? Next, b minus b. So minus 1 cos bt. So here b is how much? 1 only. So here cos u. Okay. Limits are from 0 to t. Now let's see, we are going to solve this. So now I have to put my u values in u only. Okay, t and g. So let's write e power minus t sin t plus cos t. Next, lower limit, e power 0 is 1, sin 0 is 0, cos 0 is 1. So we'll get minus 1 by 2 e power minus t sin t plus cos t minus 1. So write this formula in your formula sheet. Okay. Next we have question, Laplace inverse of 1 by s square plus a square whole square. So now we need to construct by convolution theorem. So in this case we can write it as, we need f bar of s and g bar of s, no? So we need two terms in denominator. Okay. So now what is my f bar of s? Is equal to g bar of s is equal to 1 by s square plus a square. Okay. This is also this only. G bar of s is also this only. So now I'll find Laplace inverse of f bar of s or g bar of s, which is 1 by a sin at. This is my f of t. Okay, this is also my g of t. Okay, so now by convolution theorem, what f of t into g of t is equal to Laplace inverse of f bar of s into g bar of s equal to this, no? So let's put directly by convolution theorem, integral 0 to t f of u. So here write f of t into g of t, 0 to t. What is my f of u? This. In place of t I should put u, right? So let me write it, sin au I'll get. Next, what is my g of t minus u? In place of this t I have to put t minus u. That's it. 1 by a sin a t minus u du. Okay. Next, I'll take a square common, okay, and we'll multiply with 2 and divide with 2. So see, 2 sin A sin B. What is the formula? Cos of A minus B. So AU minus AT minus AU. So it will be plus minus cos of A plus B. So A plus B means AU plus AT minus AU. So this will be cancelled. So we will get cos of 2AU minus AT minus cos AT du. So now we have to, what is this? Sine 2AU minus AT. Here A and T are constants. So only we'll get 2A in a derivative. Minus this whole term is constant. Don't write sin AT by something like that. This whole term is constant. A is constant, T is constant, so cos AT is also constant. So we should treat it as a constant. So I'll write U into cos AT. Why I'm writing U into cos AT? The limits are from 0 to T. So because see, if I have 2 du like this, so how do I write this? I write 2 into U. Why? Because 2 is constant. So in the same way this is constant, so I'm multiplying with it with U. Okay, next, so in which place I have to substitute? These are my U limits. Wherever U is there I have to put it. So sin 2AT minus AT. So sin AT minus here U. So I'll get T cos AT minus lower limit. If I put 0 here, I'll get sine of minus 80. That will become minus sine 80 by 2A. Minus this whole term will be 0. So let's write 1 by 2A square. So minus minus plus. So I'll get 2 sine 80 by 2A minus T cos 80. So what is my final answer? 1 by 2A square into sine 80 by A minus T cos 80. Okay, this is my final answer. We'll do one more question. Before we have here A square, now I have 4. So my A is 2. Okay, let's find how this we are going to do this. Let f bar of S be, I'll take it as S by S square plus 4, which is also my G bar of S. So this is nothing but, the question is find this by convolution theorem. So I can write it as like this now. So that's why this is my f bar of S, this is my G bar of S. Now what is my Laplace inverse of f bar of S? This will be 2 square. So cos 2t, which is my f of t. This is also my g of t. So by convolution theorem, what I know? Laplace inverse of is f of t integral 0 to t f of u into g of t minus u. So this is my convolution theorem. So now I have to substitute. I want f of u. What is my f of t? Cos 2t. Therefore 0 to t, write this again here. F of u will be cos 2u. G of t minus u will be cos 2t minus u. In place of t, I have to write t minus u. Okay, du. So now 0 to t, which formula I can do? 1 by 2 into 2, so that I can write it in the formula. So I have 2 cos A cos B. See here, 2 cos A cos B, cos of A plus B plus cos of A minus B. Okay, so what is my cos A? 2u. So let's write cos of A plus B. So 2u plus 2t minus 2u, and cos of A minus B. So 2u minus 2t minus minus plus 2u. Okay, so now 1 by 2, 0 to t, cancel. I'll get cos 2t. Here 2u plus 2u, 4u minus 2t. Okay. What is integration of cos 2t? It is a constant. Okay, with respect to u we are doing. So I'll write u into cos 2t. This is my constant. Next, cos of 4u minus 2t is there. So I'll get sine 4u minus 2t by inner derivative is 4. 0 to t are limits. So now I have to substitute in place of u here. So I'll write t cos 2t plus here 4t minus 2t is sine 2t by 4 minus lower limit. Put 0, it will become 0. If I put here 0, minus sine 2t I'll get by 4. So now minus into minus plus I'll get. So t cos 2t plus 2 sine 2t by 4, which is, so my final answer is t cos 2t by 2 plus sine 2t by 4. Okay. This is very important question for convolution theorem. S minus 2 into s square plus 1 using convolution theorem. So now what is my f bar of s? 1 by s square plus 1. Z bar of s is 1 by s minus 2. See, wantedly I took f bar of s as this because I want to put t minus u in this and t u in this. Easy one. Okay. Okay, so let's do it. So what is L inverse of f bar of s? Sin t. Okay, which is my f of t. L inverse of g bar of s, 1 by s minus 2 means e power 2t, which is my g of t. Now 0 to t, what is f of u? F of u means sin u. What is g of t minus u? E power 2 into t minus u. Did you understand? Before, if I took ulta, instead of here I should have written t minus u, which I don't want, it will be lengthy. So I want to do it in this way. And also I have a formula. If I already told you before, we also wrote in the formula sheet this formula. Whenever you see some sign of cos with e power at, we have this formula e power at by a square plus b square into a sin bt minus b cos bt. So let's apply that formula now. Before applying, please see what is a here. Okay, let's, with respect to u we are doing now. So this is very important. Sin u into e power 2t minus 2u du. So what is constant? E power 2t is constant. Okay, so I'll write it outside. E power 2t. Outside I'm writing. So inside what is left? Sin u into e power minus 2 is only there. Now see the formula. Integral, here with respect to t, here with respect to dt, here with respect to u. Okay, so now my a is minus 2 and b is 1. So now apply formula e power at. I should write e power minus 2u by a square plus b square. That means 4 plus 1 5. Okay, a sin bt. So minus 2 sin d sin u. Okay, with respect to u, and minus cos u. Okay, so into this is also there. That's it. So here you'll get limits are from 0 to t. Okay, so now let's substitute this in u place. Okay, so I'll get e power 2t, e power minus 2t by 5 into minus 2 sin t minus cos t. Okay, minus, put it 0, anything to the power 0 is 1, minus 1 by 5 times sin 0 is 0, cos 0 is 1. So I'll be left with minus 1. So this is plus. Okay, directly I'm writing minus 1 and multiply, it became plus. So now this is your final answer. If you want, you can multiply this, then you'll get e power 2t into e power minus 2t. What it will become? 0. I think 1 by 5 you'll get. Okay. So minus 2 sin t minus cos t by 5 plus e power 2t by 5.